Alright guys, welcome to the next lesson, atmospheric pressure. This is the lesson that comes after the pressure in a liquid at rest lesson. So, first things first, I want you to just complete this quick recap that's on your screen. Complete the pre-starter activity in your books. Look at the water container picture on the screen. I want you to fill in these sentences below using the key words to explain why water escapes from the bottom hole at a faster rate than from the top hole here. So press pause, give that a go. When you're ready for the answers, press play. Okay, so now let's go through the answer together. So the first sentence is going to be pressure increases with depth because at a greater depth there are more water molecules above a surface and their weight contributes to the pressure. This causes the force pushing the water out of the container to be larger, so more water leaves the lowest hole in a given time. So that's your recap. Make the corrections that you need to make, and then when you're ready, we're going to move on. Pause the video if you need to. I'm going to move on now. So, atmospheric pressure. That's your title. Write it down. I expect you to be able to understand why the atmosphere exerts pressure. I also expect you to be able to calculate using the pressure equation. That's grade 7, and to be able to explain how altitude affects the atmosphere in terms of density, in terms of pressure. We'll look at that later. That's grade 7 to 9. For literacy, as always, I expect you to write with the correct use of keywords. So, first and foremost, what's going on here? Well, what you've got is a dog that is trying to pull off what appears to be a rubber suction cup. Now, the question really that you should be thinking of is, why is the dog having a difficult time actually pulling off that suction cup from the floor? Well, let's talk about it. Here is a cross-section of a suction cup on a wall tile. So we're not looking at a floor, we're looking at a wall here. Same principle though. So let's think about it. How does the suction cup stay on the floor, or in this case on the wall? Well, look at these arrows. What do the arrows actually show you is going on? Well, there is a force being exerted onto the suction cup from the outside of the actual cup itself, and that is because of atmospheric pressure. So there is a force being exerted on the suction cup due to atmospheric pressure. Now, is there any atmospheric pressure at this point here between the wall and the inside of the cup, or the cap in this case? Well, there isn't. Only on the outside of the cap or cup, whatever, do you have a force being exerted due to atmospheric pressure. So in other words, you only have atmospheric pressure acting on the outside of the cap, not from within inside it, between the wall and itself. Now, what happens to the air inside the cap? Because remember, the air inside the cap is trapped. What happens to the trapped air inside the actual cap itself, or cup, I don't care what you call it. What happens to that trapped air when you press the cap onto the wall? What do you think is going to actually happen to the trapped air? The trapped air is going to be forced out. You are forcing out the trapped air molecules from within the rubber suction cap itself. So, based on that then, I want you to give these two questions a go, use these keywords to help you, explain why the atmosphere exerts pressure, explain why a rubber suction cup stays stuck on a wall. Remember, this whole idea of pressure is all about air molecules colliding with each other and other surfaces. And in doing so, the collisions they have with each other, that can be determined as impacts per second, or impacts, small impacts that collectively have a large force being applied. Just keep that in mind in terms of this whole idea of why the atmosphere exerts pressure. That's very, very important. Air molecules colliding with each other, the impacts that are due to atmospheric pressure. So, press pause, give the questions a go. 5 minutes to do that. Time yourself, and when you're ready for the answers, press play. Okay, so now let's go on to the answers. So question 1, green pens at the ready obviously. Explain why the atmosphere exerts pressure. Well, it's due to air molecules colliding with surfaces, with each other and surfaces. Each impact exerts force on object or on object surfaces. Question: to explain why a rubber suction cup or cap stays stuck on a wall. Mark 1. Pressing the cap forces out trapped air. Mark 2. Between the cap and the wall. Mark 3. The force due to atmospheric pressure acts outside the surface of the cap only. So, that's your first objective, understanding why the atmosphere exerts pressure. Make the corrections that you need to make. Give yourself a mark out of 2 for question 1 and a mark out of 3 for question 2. And when you're ready, let's move on. So, calculating pressure then. You should recognize this formula triangle. You should recognize the formula, and that is pressure equals height multiplied by density multiplied by gravity field strength. It does get slightly different though. I want you to just know that in this particular context of atmospheric pressure, height is to be defined as the overall height of the model atmosphere that we're dealing with. Density, we'll be talking about the density of the air, hence atmospheric pressure. It refers to the density of the air. Now you could be given 2 pressure values. You'd have to work out the difference between them. And if you're given the area of a flat object, multiplied by that area if relevant. Remember, always convert units if needed. For example, kilometers has to be converted into meters, and you do that by multiplying by 1,000. Kilopascals to pascals, you convert that by multiplying by 1,000. Make sure you know those conversions. So, here are some questions for you to think about. I want you to press pause and give them a go, and when you're ready for the answers, I want you to press play. Give yourself 6 minutes to do it. That's what it would be like in a normal lesson. But obviously you can take more time if you need to. I'll read the questions through with you. Each window of a passenger jet has an area of 0.04 meters squared. When the jet, so that is an area. When the jet is at a certain altitude, outside pressure, that is the pressure of the air outside the plane, outside pressure of the atmosphere is 40 kilopascals, and the cabin pressure, that's the pressure within the cabins of the aircraft, is 75 kilopascals. The pressure is slightly higher. Calculate the force on a window due to this pressure difference. So you need to think about force. So you should not just be using this equation. You also need to think about the first equation that we looked at in terms of pressure, which is pressure equals force divided by contact area. Look back at your previous notes on that. Look back at your notes for the pressure and surfaces lesson. So that's question 1. Question 2 is a bit more challenging. It's a 5-mark question. This is grade 7, question 2. Use the graph to estimate the mean density of the air in the atmosphere between sea level, which has a pressure of 100 kilopascals, and an altitude of 30 kilometers. Give your final answer as a whole number. So you just don't worry too much about getting a perfect number here, but just give yourself, just roughly estimate the best you can what number you reckon that is across the graph, and then when you're ready for the answers, press play. Otherwise, pause the video now and give the questions a go. Okay, so now let's go through the answers together. So question 1. Question 1, pressure difference equals, remember, pressure difference equals pressure difference times the window area. So in this case, we need to work out the difference in the pressures that we are given. We're given 2 values, 40 and 75. So I will do 75 minus 40 multiplied by 0.04 meters squared. That can also be, that's for 1 mark. The next mark is, well, remember you have to convert your pressure values into pascals. We do that by multiplying by 1,000. The difference between 75 and 40 is 35 times 1,000. That's 35,000 pascals multiplied by 0.04 meters squared. That gives you a force of 1,400 newtons, and that's your final answer. Question 2. Sea level we know is 100 kilopascals, which is also known in this case as 100,000 pascals. Now at 30 kilometers above sea level, if you look at the graph, I mean, I made the rough estimation that, roughly speaking, is 2. I'm going to say 2, roughly 2 kilopascals. So based on that assumption, that would be equal to 2,000 pascals. That's Mark 1. Mark 2, I need to work out the difference in height. So I've been told sea level, which is 0 kilometers above sea level. So that, that altitude there is 0 kilometers, and an altitude of 30 kilometers. Well, the difference between 30 and 0 is 30 kilometers. So 30 minus 0 is 30 kilometers. That stays the same, but it has to be in meters. Times it by 1,000, and you get 30,000 meters. That's your second mark, Mark 2. We need to work out the difference in pressure. We know that at sea level pressure is 100,000 pascals. The pressure 30 kilometers above the sea level is 2,000 pascals. So that's going to give you a difference in pressure of 98,000 pascals. And now to work out density, you rearrange the formula, this formula here, to make density the subject of the formula, and that would be pressure. That would be density equals pressure divided by height times gravity for mark number 4. Put the numbers in, 98,000 divided by 30,000, your height, which is 30,000 meters, multiplied by the force of gravity, 9.8, and that would give you a density of 32 kilograms per meters cubed. And that's your final answer. Make the corrections that you need to make. That is your second objective, and now we're going to move on. Well, let's think about this graph then. Here it is again. Let's look at the graph. What does it actually show you? As you go along the x-axis, what does it actually show you? As altitude increases from, let's just say from 0 to 5 kilometers, look at what's happening to the pressure in the atmosphere. As altitude increases, the atmospheric pressure decreases. Well, let's go back to what pressure is. What is pressure? Can you think of what it is? What is pressure? Using these keywords, it's air, in this case, air molecules colliding with each other. Well, now, what do these particles exert on each other and on surfaces, including their own surfaces? They exert a force. Now, what is there less of? As you go higher up in the atmosphere, what do you have less of? Now, hopefully you'll be thinking you've got less oxygen, you've got, which remember is a gas molecule, you've got fewer gas molecules. In other words, you have less air, the mixture. Because remember, air is a mixture. You have fewer air molecules or fewer gaseous molecules as you go to a higher altitude. Now, what does that mean? What does that really mean? Remember, we're still thinking about pressure. Keep that in the back of your heads. What does that really mean? Does that mean that the atmosphere is getting more dense, or it's getting less and less dense as you go higher up in altitude? It gets less dense. That's what's happening. It's getting less dense. Now, the weight of air molecules above the object's surface, which could be a plane, let's say, the weight of air molecules above any object surface also contributes to atmospheric pressure. Weight is important, folks. Remember, weight is a force. The total weight of air molecules above the object's surface also contributes to atmospheric pressure. Now, if there are fewer molecules at higher altitude, how does this affect the weight of air? Well, there's going to be less weight. The weight of the air will decrease. This is actually why the atmospheric pressure decreases as you go higher in altitude, because there are fewer air molecules at a higher altitude, the atmosphere is less dense, the weight of the air decreases as well. And remember, the weight of air molecules above the object's surface also contributes to atmospheric pressure. That's extremely important to keep in mind. This is actually one of the reasons why jets have pressurized cabins and emergency oxygen masks, in case the cabins lose pressure or lose air, essentially, and to help you breathe safely at high altitudes. So here's a question for you to try. I want you to press pause and give it a go. Use the level descriptors to guide your writing. You should include the definition of the atmosphere as well as a clear and detailed explanation of why atmospheric pressure decreases with altitude. Explain why atmospheric pressure decreases with altitude. 6 marks. Use all the keywords in your answer. Use other keywords if you want to. And then when you're ready for the answer, I want you to move on to part 2 of this video on the YouTube channel. So press pause and give it a go. And when you're ready for the answer, move on to part 2.